all have been discussing and learning a lot about data centers and how the technology for the data center has been evolving over the past few years in India. We also heard a lot about sustainability, which is being the hot topic for today, because we all know that sustainability is the key for us to retain the livability of this planet. And data centers today are growing by leaps and bounds. I mean, just a few years back, the installed capacity of Indian data centers was somewhere around maybe 300 to 400 megawatt of IT. Today, very shortly, we are touching a gigawatt of installed capacity in India alone. And I'll say very soon, maybe next 5, 6 years, this capacity may also double. So from the perspective of overall power consumption for the data centers, we are on a very steep path of growth. When it comes to data centers requirement for cooling, over the past 10 or 15 years, I have seen the data centers really grow their average density very drastically. Around 15 years back, it was very common for somebody to have a 3 kilowatt or 3 kVA rack, okay, per density. And somebody if was doing 8 kilowatt density, it was considered as a very high density. Today, that scenario has completely changed. I would like to understand from both of you about where do you see the data center densities going and what impact does it have on your design approach for this?
Very good afternoon. Am I audible? Am I audible? Am I audible, sir? Thank you. So many empty seats still around here, so I always have this challenge of seeing it in the second half of the day. It's very difficult to get people after lunch, but after lunch I saw 2 sessions for full. Probably they wanted to have a small break, but sent you out for a coffee or tea. But I think people are still walking in. It's good to see people still here. I think good afternoon, everyone. One thing I would really appreciate the Chennai audience, highly technical, highly committed. And second thing is the interest in knowing what's happening in the industry is very, very high. So the kind of questions and the quality at which it comes in, very good. Thank you so much for being so loyal to the industry. Atul, look, I mean, I've been in the industry my name is Ramachandra. I work with L&T as a data center design head. And it's been a long time that, we have been seeing high density is coming. People talked about 3 kilowatt, 5 kilowatt, and suddenly the OEMs like Schneider, many other people said that 5 and above, you cannot do it in a normal cooling, come out with the in-rows, so high density up to 10 kilowatt. But when we saw the deployment in the industry hasn't been too big, so everybody talked, even Intel talked about it, 5 kilowatt is gone, we are talking about 10 kilowatt, 16 and 20. But I think that in the middle phase, we did not see huge amount of density increase. It was all on the papers to an extent, but some of the data centers had, like say Indian mathematical institutions and various other organizations, but not everywhere. And today, if you see, I think it's gone leaps and bounds in terms of the number. If we talk about 10 kilowatt, add another suffix, another 0, it becomes 100 kilowatt. You talk about 3 kilowatt or 5 kilowatt, another suffix of 0, it becomes 50. Now it is throwing challenges to all of us. One, really, is it going to be so much? Or is it going to be the same story of what we had earlier? 10 kilowatt is coming, 16 is coming, but never came out to an extent. But I think in the technology today, we are seeing those 30, 50s, and 100, basically for various reasons. I think we will talk about it. I will not touch upon everything in one subject. But yes, we will see, and it is evident for us based on what's happening. Since morning, we are talking about bandwidth, connectivity. The 70% of Indian population is on the internet. And 24 GB to 62 GB per day of usage, storage, connectivity, everything, e-commerce, everything is going to be connected and used everywhere. So there will be connection, there will be storage, there will be accessibility. So that means there will be data center. So I guess it will be very huge, very, very good times for all of us as a designer and also a user so that your latency is reduced. So I think we'll talk about it much in the next points. Thank you.
Thanks. Chandra, Mohan, I would like to just briefly touch base on what are the key drivers for this. I mean, RC also mentioned about where it is coming from the general public point of view. But as a data center developer, when you're looking at it, do you see more of the change in demand of average load happening from enterprise side, from hyperscaler side, and the newest entrant on the block is AI? Where do you see that?
Yeah. Uh, Thanks, Atul, for having me as part of this panel discussion. Good evening, everyone. I am Chandra Mohan. I represent an organization called EverYondr. So we are into a build-to-suit model for hyperscalers, basically the cloud service providers. So coming to your question, Atul, see, basically right now, the data center market per se, if you see that the last 5 years is where the humongous growth is happening, starting from, say, 2019, where the hyperscale providers started coming into this market, where you talk about rack densities in the range of around, where the average rack density is in the range of around 20 kilowatt per rack. So that's where the main drivers is, where the cloud providers and the hyperscalers are where the major drivers in terms of the rack density is going up. So, and right now the average is around 20 kilowatt per rack. However, their peak demand is somewhere around 40 to 45 kilowatt per rack as on date. And which is going to exceed, that is what the market projection says, is that they are going to touch to around 80 to 100 kilowatt from an hyperscaler perspective wise. So that is one part of it. So there are enterprise data centers, which are there traditionally around 8 to 10 kilowatt per rack. What I feel is that density is also going to increase further in the next 5 years down the line. As you know that the enterprise customers are also going to adopt AI and ML, the major new innovation and technologies which are going to drive this thing, which has major verticals. In terms of verticals, you talk about whether it is a finance industry vertical or whether it is a manufacturing vertical. All these industries are going to adopt AI in a big way. So due to that, the enterprise data centers are also, the demand is going to increase from an average load per density.
Okay, thank you. So I'm just taking the same question forward. Since there's a change in load and obviously a huge step up in terms of average densities, are there perceptions of risk of data centers operation changing because particularly with the low density and the challenges it poses for the cooling? Any of you can
Can you redefine what was your question? Is it the risk towards the design, or is it risk towards the operation, or both?
It is both. So let me just give a background. Okay. So for example, Uptime Institute is doing a lot of heavy research every year around the globe. And for last 11 years, we have been doing annual outage analysis and data center trends as well. So what used to happen is typically you would have electrical failures as the primary cause for most of the outages, followed by cooling. What we are seeing recently is cooling is taking the next step and is slowly growing in terms of the risk factor in the data centers. We also saw last year wherein the outages happened across UK because of heavy ambient temperature increase. So do you think, so my question was around the risk that the increasing densities are posing to data center design and operation, and how you as a data center designer and provider are looking at it.
Yeah, please.
Yeah, I think, look, there are two things, right? One is the very heavy density where it definitely brings in a big challenge. Now, the topic is not about cooling, right? So the first thing is, how do you remove the heat? So from the source. If somebody says that I need to cool the data center racks, I think we need to revisit ourselves, see what needs to be done. Should we remove the heat, or should I just throw the cold air? Maybe cold air is required, but the idea is to remove the heat from the source. When you design, I think since morning we have been hearing about the different type of designs required with the high density and all. It throws a lot of challenge in terms of how it will be architectured in terms of the power. Definitely the power, if you know what you are bringing in, what kind of cooling, whether it is immersive cooling or some sort of a cold plate cooling, and what kind of inputs does it require. That is one challenge which we can work out. It's not very easy to do it, but definitely, yes, it's possible to work around. When it comes to the operation of a data center, to an extent, it throws a different challenges in terms of the skill sets, who manages the data center. It's not going to be, once you have an immersive cooling or some sort of a cold plate cooling, you may not see as much as what you saw in typical data centers where the cold air is thrown below the raised floor or in rows. So some of the things could be immersed. You don't even know what's happening. As long as it's working, it's fine. In such cases, when you have a mix of your immersive or cold plate plus your normal air cooling required for rest of the other equipments, if the other secondary cooling, supplement cooling, if it fails, it definitely causes an issue. But from an immersive cooling perspective or a cold plate cooling, as long as systems would work, it will work. But what my point is, we used to have a thermal runway challenges earlier, right? So change of temperatures going on and off within certain period of time, if it increases to a certain level. Yes, that would have created a lot of problem, because I was doing a lot of energy audits when we used to have temperatures varying, and the system used to send an alarm saying that I'm going to shut down now. So that may not be a challenge right now, right? So it's going to be cold plate where the processor, the heat is removed. So the job is to actually ensure that processor heat removal is brought up to a very nominal level. It's not going to take out everything from there. So it cools down based on the processor requirement. So that's what's going to be. But again, from the managing the data center perspective, it may change a little bit, but again, there is a skill sets and the trainings required. How do you manage such data centers? So that's where I see from a design perspective and the overall management of a data center.
Okay, thank you. So I think I completely agree with the thermal right-away issue that data centers pose typically with the air-cooled systems, and definitely the cold plate and submersible cooling is much more predictable. But I have another top-up question to that. I mean, some of those technologies are new. Okay, maybe we have internal, completely tub-based systems, but they pose a limitation in terms of what kilowatt you can achieve in a particular for per rack. We have cold plate systems, but there are issues because most of the time these have been used primarily in the research labs where the load used to be high performance computing and all of that. Today it is coming into the production environment wherein the uptime and availability of those systems is much higher. So I don't know, definitely in your individual organization, you must be trying to work around with these systems, trying to evaluate and implement them as well. So do you think there are any favorable systems that you are individually preferring or liking in terms of the performance, in terms of their maintainability? Because you have multiple options, like you have cold plate, you have direct to chip, you have submersion cooling, and maybe something else. So what are your opinion? Chandra, Mohan.
Yeah. Say, the type of cooling solution, what you design, it basically depends upon your server TDP. That is the thermal design point, actually, or the thermal design power. So what the industry or what the technology they say is that up to 700 watts per, whether it is a GPU or other thing, you can still manage with an air-based cooling. So the moment you exceed the 700 watts, the GPU power, that's where the challenge comes in terms of cooling these GPUs, where you are inherently forced to go for a liquid-based cooling. So coming to the point, as RC has pointed out, that there are certain challenges in terms of liquid cooling. I do understand that. So currently, there is two different technologies which is available. One is the DLC-based, one is the direct liquid cooling to the chip level, where the cold plate, it goes to that. The other is the immersive-based cooling solutions. So when you consider DLC-based cooling solutions, it is much more easier to adapt into a present environment in an air-based cooling system, where if your data center is designed for air-based cooling systems, it is much more easier to accommodate a DLC-based cooling system with a minor tweaks in your chill water temperatures and other things, which can be very well be done actually. So that is one point of it. So right now, the industry benchmark is what it is. It is at up to around 30 kilowatt per rack is the density, is the benchmark. Below that, you can, up to that is what the air cooling technology or air-based cooling technology is used actually. So the moment you exceed this 30 kilowatt per rack densities, going further upwards on the north side, then you have to go for a liquid-based cooling. And what kind of a cooling solution, that has to be done on a case-to-case basis. I still agree with RC that that is the way forward in terms of as the load density increases. However, to second, one more point on that, when you go for a liquid cooling, the challenges, the earlier point which RC has talked about in terms of operational and maintainability point of view, that you need to look into it. Because basically it is what is happening is that the moment you supply a cold water or a dielectric fluid into a cold plate, and in case of a failure in that cold plate and there is a leak in the piping system, the thermal runaway which RC was talking about. So the thermal runaway in a liquid cooling system is going to rise in case of a failure, since due to the very high heat ratio which is getting generated. So within a matter of few seconds, the cold plate will become an hot plate actually. So these are the emergency operating procedures. So you need to have a very robust emergency operating procedure in place, so that in case of any failure scenarios, you have a very defined, robust system to mitigate all this risk, and so that your IT does not have a major shutdown.
So I just take one cue from what he said. I think we talked about the limitations of air cooling up to about 20 kilowatt. We had the fans and everything, boosters coming in and various things in the earlier days. We have a team here, LNT design team, so I was just discussing with them yesterday. All the designs, what we do here in our LNT is to scientifically prove that whether it's going to be possible or not. So we use a lot of other software like Six Sigma and various other things to run a CFD before we do it. There was a beautiful question came up saying that, we said 15 kilowatt per rack, maybe okay, 20 is okay, but 30 is just not possible with the fan wall unit. No raised floor, it's fine, but it just throw it through the baffle. I said, no, it's not going to, maybe we'll just do a CFD. The beautiful question came up saying that, "Arey, ye to kaam kar dega yaar." We were doing, sorry to use Hindi, but it was about 40 kilowatt per rack or 42 odd. We were trying to see it in the data center with a 4 containment. When we ran through our design, everything was beautiful, because the elevated temperature inside the data center that could make, they were pushing the ASHRAE envelope, so they were going beyond that. So the point I'm making here is that it is just not the products what you use, but the professionals and the engineers, how they put it together on the white space. We used a methodology of how much of air is required, what kind of air is required to be pushed into the rack, and how much is the volume required. Higher density doesn't mean that your data centers go smaller. Though you use your liquid cooling or a DLCs like Atos or Craze and come in, or somebody else like Coldplate come in with various other names, I don't want to take them, but you will still have air-cooled systems within the same rack, because those chips, which are made by NVIDIA or AMDs or Intel, today just came up saying that they are much powerful than the B200. So the point is that there will always be those chips which needs to be cooled directly, but the rest of the system on the motherboard still needs an air. Right? It could be 60-30 or 67, whatever numbers it comes out of 100. But the point is, you will still need that. You need to remove that heat from there. So the beautiful way of doing that is to prove it yourself internally with certain tools and tackles before you start putting together at customer. That's one verification. Number 2 is, yes, I think 100 kilowatt, 120 kilowatt, we keep hearing about it. It will happen for sure. That's something which I have seen of late.
Thanks. So I definitely have a takeaway that L&T has very, very strong engineering team capabilities. And based on your answer, still it is a mixed approach to most of the cooling solutions, because you may still have a mix of very heavy density racks, partially mixed with low density servers, and air cooled plus maybe direct liquid cooled, or those kind of an approaches may be more practical at this point of time, unless we really go in most of the racks wherein 40 plus density is the common one. Okay, now since we're talking about the high densities, and whenever we talk about high density, we talk about a huge power being consumed by IT, and in turn, a huge power consumed by cooling to take away that heat. Now, conventionally, cooling has been always termed as the biggest consumer of power in the data center other than IT. Okay, we have been always allocating almost 40% of IT power towards removal of that heat from the room. Okay, and that's why there has been a huge pressure, and I think as an industry at a global level, we have put in a huge effort to reduce that. Just for everybody's information, based on the surveys that Uptime Institute does every year, we have seen a steady decline in the PUEs over last 10 to 11 years in the globe. The average PUE at a global level was somewhere around 2.2, maybe 2.5, around 11 years back, and it has come to around 1.57 PUE at a global level. This will be largely varying based on which part of geography we are looking at. I mean, we as being a tropical country, our regional average PUE is around 1.67. The new age generations of the data centers may be pushing the envelope, in a better way. But still, the average PUE cannot go and match anything that Europe can do because of the typical heat.
So just on the touch, I think you touched upon a very important part, the sustainability and the energy. You got such a heavy density racks, 100 kilowatt, 40 racks, you almost, done. One big room, small racks and everything. But if you look at the traditional design, in which you used to use your air-cooled chillers or some other way of cooling, the amount of power which takes into your mechanical is about 35 to 37. Again, it's debatable. Some may say 40, some may say 35. But yes, the huge chunk of power goes into the cooling. As you rightly said, your survey from an uptime perspective, the average is about 1.52. But if you go to customer with 1.52, the door is already shut. They don't even want to talk to you, right? So they're talking about subset of 1.3, 1.35. And again, they say, my design is this, my peak is this, but my annual average should be less than probably mechanical touching at 1.09 or maybe less, and electrical touching at something about 1.1. Definitely, there is a possibility, even if you have a high density, because you're reducing the entire cooling requirement. One, because of your high temperature coming in. You may not need the chillers as required because it works at 30 plus temperature. Then you don't need a real conversion into your compressors. That reduces quite a lot. That's the big chunk of power which is going to guzzle. And the second thing is probably today we have got a lot of dry coolers coming in, the various technologies which are complementing to each other to ensure that the big number or the big ticket which everybody wants to be on the bandwagon of sustainability and the PUE, not to forget another thing which is huge today, everybody is talking about is the water usage effectiveness. People say there's a shortage of water, what do I do, kind of thing. But the point is, yes, we have been in the era of PUE. We have seen it from 2, 1.5, and then coming down to subsets of 1.3, 1.35. Going forward, I guess there is a debate about why only PUE. That's where the NVIDIA and the AMD clusters are coming in. How much is the compute power or compute output vis-a-vis how much power is being taken, right? So that's another IT fraternity talks about it because my teraflop or whatever we talk about in terms of churning of data and how much power do I use. So it is not just the infrastructure, power and mechanical and the electrical, but it's more to do with IT. So it's going to be a very beautiful the orchestrated chaos in terms of understanding what will be the best methodology of using the efficiency for data center. That's what I want to just.
That's a beautiful point you touched. Just to add one sentence is based on the flattening of the PUE, what we have done over the period is we have adopted to the ASHRAE standards. We have really increased the temperature at which the servers were being operated, okay? And that has taken us to a great level where we are standing today and whatever PUEs we are talking about. But it can only take us so much, okay? So most importantly, I take many of you are users of IT, maybe the CIOs, maybe driving your IT strategies. One of the key factors that we have observed is it is time for each one of you to look at how your IT is being used. We have seen a lot of customers wherein they had ghost servers sitting, consuming power, doing nothing. Okay, so it is important for you to see what is the dynamic and have much more dynamic control on the way your servers are being utilized. Understand what is the loading percentage, how that can be increased, because a server running at 30% load is almost consuming the same power as it would do at 80%. Maybe slightly lesser, but it is not doing as much work. So it is important to have your IT working much harder rather than putting all the pressure on your facility guys to improve the PUE, because that's where the efficiency is going to come from. Chandra, over to you.
Yeah. Say, with regard to PUE, I have certain key points. So here, as rightly pointed out, both Atul and RC, the industry is looking for a better PUE in 1.5 less than 1.5. Right now, they are talking about 1.4 or less than 1.4 and other things. So all this PUE is in relation to air cooling kind of a thing that is being established as a market standard and other things. So the moment you go into a liquid cooling with a high density kind of application, say right now, just for a reference, I would like to take an input of NVIDIA GPU. So there is first, the earlier version, I think if you talk about the recent launch of Blackwell, which RC was saying in the GTC conference 2024, which Jensen Huang was presented it. So that is, when compared to that, in the earlier version which is the H100 GPUs. So the H100 GPU was consuming around 700 watts per thing. Whereas the Blackwell GPU, which is able to perform close to around thrice, I mean, I think it is 3 times the computer power in terms of whether it is a training model or whether it is an inference model. It is 3 times in terms of a thing. So, and yes, there is one point in this entire, during the launch he has presented is on the water temperature, where he was talking about a water requirement of, on a secondary side, from a 25 degrees centigrade and the exiting point at around 45 with a 20 degree delta T. Even though it is a bit technical, why I am saying that is, say, the cold plate size is not increasing, the power density is increasing due to the processing thing. So you cannot define the law of physics. You cannot say that I will have the same cold plate size, I will increase the power density in order to increase my compute power. So what is the best option? The next best option is that you reduce the water temperature on the primary side in order to remove the greater heat density from that thing. So this interoperability, how this PUE factory is going to pan out in the, especially on the AI and the more adoption of AI and other things, that needs to be looked into it. That is my perspective on this. And going forward in a data center, you have to also look into from an interoperability perspective wise. What kind of customers, whether you are going to cater to a cloud service based customers or whether to a hyperscale kind of a customers, both customers are requiring a different kind of a inside our cold aisle temperature or whatever the design requirement is. So these are the things which will play into the going forward in the next 2 to 3 years down the line. I think this space, that PUE right now, if you say that going forward, it will be a misnomer. You have to look at from an overall holistic perspective wise, from an IT and from a facility perspective, both put together, and you have to look into it.
Great, thank you. Thanks for that. So we are almost touching the time that we have been given. So we can spend 5 minutes in case there are any questions from the audience. Can somebody pass on the mic, please?
So just a question, we are pushing the operating temperature limits. So is there a danger that we might go too high given the scenario of power failures? Because you're talking of both on the air and the liquid, we are really pushing. So is there any risk associated with that?
See, what I will say is that right now the TDP which they are talking about, the thermal design where they are pushing it from 700 watts, they are forcing it to go towards in the upwards of around 1.2 to 1.5 kilowatt. So as you push the power processing, the GPU power, the heat density. So what it happens is there is a much more innovation in technology is happening. To be frankly speaking, I have come across many startup companies who are working in cold plate technologies, upgradation, which talks about a two-phase cold plate design, which there is a cold plate which talks about a hybrid cold plate design. So as the power density increases, the technology addressing these challenges is also coming up, and there are many industry players who are coming into this industry, startup companies which are dedicated for this from a heat removal perspective as they are working in. I think going further, the densities are going to go upward. At the same time, the technology is going to evolve, and the next 3 to 4 years down the line is the cooling market will go exponentially in a different kind of a cooling solution.
Dave, if I've understood your question correctly, what you said was the increase in the pushing the air temperature to a level, is that going to cause a problem for the processors? Is that correct?
In the event of a power failure,
Yeah, yeah. I guess I had a very fortunate incident in one of my customer in Mumbai. So he said my IPMI inside the server, it's sending mails because it's saying I'm reaching 80 degrees of temperature in a normal condition because of some short cycling inside the inside the rack. The point I'm making here is that everybody wants to be safe. It's my personal opinion, right? So today, the normal servers can actually handle beyond. It's about, we say it's 27 as per the ASHRAE, and they do not. I mean, ASHRAE is also, when I talk about ASHRAE, it's about the IT, the manufacturers of servers and chip manufacturers, and the HP who actually puts it together, like say Dell, whoever. Who carries the warranty? I mean, I use Intel, I use AMD, I use something else, but it comes as a total, the solution to the market. Now, if I can increase the temperature, not an issue, and I've come from the age where the data center used to be 19 degrees. Today, we are talking about 27 degrees, 28 degrees. The point I'm making here is today's chip, which is available in the market on a typical air. Guys, you can correct me if I'm wrong. This is where my opinion is. This is my personal opinion and personal understanding. You can still push the envelope as long as you change your inside the servers, the power management, where the internal alarms are generated. But that's something which your IBM, I think the gentleman from IBM was here in the morning, I guess. If he's here, he can talk to us. There can be something which you can set, like your car. After 10,000, it shows that you are up for the service, right? So that can be increased if you want to. But similarly, you do not want to push your limit of your server. Every time the server is running, even till date, it reaches about 80 degrees for sure. We are talking about air going from there and remove, and all those things are fine. But it's at the end of the day, who owns the responsibility of that? Coming to today's world, just to name, AWS goes beyond. They don't care what AWS says. Some customer says, I will push it. And another customer in Mumbai, they are also pushing from 26 degrees to 27 degrees. Every degree you increase, you save quite a lot of money because every hour your data center is running 24/7. So when I talk about today's chips, you talk about NVIDIA and Intel, I think they have already pushed the envelope and they have designed. And they're talking about 31 in a normal condition. Whether it is connected through your cold plate, remove the heat from there, or it's just the air-cooled NVIDIA has got a pods. It doesn't do anything. It just gets there inside. It gets the normal air out. I think they have a higher envelope. It is okay. I don't see any issues as long as for me, it has more to do with the OEMs who claim the warranty. What if that fails, right? So that's how it looks like. But definitely the servers and the chips can handle that kind of thing. Again, it's not just the chips inside data center if you look at it. Again, there are the storage devices, various other things. So the temperature is not just for the servers as a chip. So probably all in holistic view, you would want to keep it somewhere at 26, 27 degrees. That's what is my understanding. If there is anything new, please add on to it. I'll be learning as well. So David, so over to you.
Got it. Thanks.
Any other questions from anyone? Or else we have been very boring, otherwise people have been just listening to it. Okay, thank you so much. I see a lot of chairs not being empty. I really love this. Oh yes, we'll take, definitely. I think we said 2 questions. If we can take one more, that would be good. Yeah.
Sir, I'm Gagan. I'm from Danfoss Industries. So my question is very basic. When I'm talking to any consultant design, right, they're always designing air-cooled chiller. Why not water-cooled? I'm still finding the answer, but I could ask all the dignitaries are there from design. So why always we are considering air-cooled will be the efficient, but as we know that on conceptual, water-cooled will be more efficient while designing the data centers.
It's who's the best among my two kids, you know? So everybody says, my first one says, I'm the best, second says, I'm the best. But the point is, I think it's beyond, the water-cooled chillers are having better COPs and IKW-PR. But today, if I talk about air-cooled chiller manufacturers, because I sit in the design and build kind of a situation today, not from OEM. I was in Schneider for a very long time. And now I see that, the air-cooled chillers are coming and saying, I would easily match what water-cooled will give you, right? That's one thing. Second is that, I guess, from a water-cooled chiller perspective, vis-a-vis your air-cooled, I think there is something to do with the capacity. It's just the higher side on the water-cooled chillers and the lower side in terms of the air-cooled. It's probably a bit of an easier way of doing it. But again, there's always a market for water-cooled. Right now, we are working on a data center which is very much multiple megawatts. We are trying to compare between the water and the air-cooled based on the IKW per TR. I guess it's a game of what is available, what's really required by the customer. Definitely, water is a resource where we need to look at. But again, it's all a closed loop and things like that. So it should work, in my view. We are open to discuss and we are open to design. Come to L&T, we will take care of everything.
Yeah, say, it is not, there is no specific graduate. We don't want to go for a water cool kind of a solution. It is, there are multiple things placed into designing a data center, whether what kind of ROA and other things, whether the availability of water, might be even one particular location or city, the availability of water, even though it might be much more water cool chillers will be much more efficient in the sense. As to add to this point, I agree that right now the air-cooled chillers are also becoming much more energy efficient. That is one due to the higher water temperature which we are going for due to the data center inlet temperature water requirement is also increasing to around 20 degrees. That is also playing a major role in increasing efficiency of the air-cooled chillers. And there are other new technologies like magnetic levitation chillers which also makes it. So my only thing is that there is no hard and fast rule unless you have a, say, data center where the uptime is your final bottom line. If you're able to give your uptime commitment, stating that with a water cool, if you're able to give an uptime to any client and other things, everybody will be good. So it all depends on that. Water, yeah, absolutely. Yeah, that is what I'm saying. Unless you have a clear-cut 10 years down the line visibility that you are sure that you will have enough water to cater to this requirement.
I think we had this discussion in the morning that building life is 40 years, MEP is 15 years, IT life cycle is 4 years. Now, if they have to make an investment in a system which requires dependence on outside water, okay, typically you are seeing that in India we are making the data centers which are close to the main cities. Okay, we are having it close to Chennai, Mumbai, Bangalore, Hyderabad, Noida. Now, these are the places where we have residential zones very nearby. And tomorrow, if there's scarcity of water, the first thing that gets the water cut from is the industries. Okay, so none of the industries today want to be in that situation where you may run an operational risk, wherein you are told, okay, manage your water on your own. You are not going to supply your water. You may not even take water from ground levels. So those are operational issues. Second thing, is other than just the availability of resource, sustainability being the key driver today. People want to have just not the power usage effectiveness better, but also want to have better water usage effectiveness. Third thing, from the operational sustainability point of view, you want to have a system which is easy to maintain, because most of the time a good system may still fail due to operational errors by people or lack of maintenance and so many other, there are dozens of reasons for that. But having a complicated system makes it more difficult to maintain it and have their SLAs standards met. So I think they're just also trying to simplify without compromising too much on the efficiency and that part. It was a good question, and I hope all of us have answered it well. And I take this opportunity to again thank Mr. Ramachandra and Chandra Mohan for spending their valuable time, and all the audience for being patient and really active and asking some really nice questions today. Thank you, W.Media.